Good morning, students. Welcome back. Before starting the numerical part of the work, energy, and power chapter, let us go for the quick revision for the this chapter in short. Work, energy, and power. In this chapter, we have learned something about the what is dot and scalar product properties of the scalar product. We have learned the work example and definition of the work done by the parallel force and the applied force. What is the work zero? Some point about it works. Positive, zero and negative work examples we have dealt. We have dealt with the work done by the variable forces. What is energy? Different forms of energy. What is kinetic energy? Definition and formula of it. We have learned or knew something about its note on the kinetic energy. Work energy theorem for the constant force and variable forces. Potential energy is definitions, examples and formulas. Note about it. Laws of conservation of energy and its examples. Conservation of forces and non-conservation forces, conservation of the mechanical energy, example using the gravitational forces and spring. Collisions considered as elastic, completely inelastic or inelastic collisions and its examples, practicals, demonstration, etc. Elastic collision is the one of the dimension and inelastic collision is one dimension. Elastic collision in two dimension, what happens? We will learn that. Power and note on the powers. Now first, dot product or a scalar product. A dot product, the symbol of multiple between the vector in represented by dot represent of the product in the scalar value. Remember this. Consider two vectors A and B making an angle with each other. Each dot or scalar product is given by A vector dot B vector is equal to AB cos theta, where cos theta can be given as A vector dot B vector upon modulus of A vector mod of B vector, as you can see on the screen and diagrams also. Suppose A dot B is equal to AB cos theta, so you will get a condition as you can see on the screen. Two different positions for the point and you are seeing that theta is changing but with respect to the reference point only. Geometrical B cos theta is a projectile of B onto A and A is cos theta is the projectile of A onto B vector. Properties of dot product, remember. First, dot product result in a scalar value. Dot product or scalar product is commutative, means A dot B, B dot A. Its distributive law is applied on that. You can say A dot B plus C vector will be equal to A vector dot B vector plus A vector dot C vector. Also remember one of the important thing, when two quantities are multiplied in same manner, you will get as equal to 1, or two different quantities are multiplied, you will get as 0. You can see on the point 4 and 5, that is I dot I is equal to 0 and I dot j will, sorry, I dot I is equal to 1 and I dot j will 0. Component of A along the B, A cos theta A dot B, vector B will be equal to A vector B cap. Component of B vector along the A will be b cos theta a dot b upon a b vector a cap. The other general properties, you know what is in 3 dimension for a vector and b vector, that is ax I cap plus ay j cap plus az k cap a b c. All the 3 vectors can be represented in 3 dimensions. A square, that is a dot a, will give you ax square plus by square, ay square plus az square. Similarly for b and c also can be done. Now what is a work? Work, see, horsepower, here work. Who is doing the work? Can you decide? Horse or a man or a cart? All are doing the work. Work, you can say, is equal to F into D, that is force into displacement. How much the particle is moved by giving a force, that is your work. Here also work is done, but here the manner is different. What is walking? So who is the one who is doing the work? A man or object? Both. But having the conversation, you have to learn something in this chapter. What is going on? Where is the work? What kind of work? What kind of energy in that? What is the transfer of the energy, etc., etc. An engine of a moving vehicle does a work. An object drop from the height falls towards the earth indicates that earth exerts force of attraction called gravity on the body, and the gravitational force work is pulled on the body towards it. So it kind of work only, but in the different way of the energy, of different way of work. Work is said to be done by the any object when a force is applied on the body produces motion on it. It can be of various way or by a various means. Work done by the force is defined to be a product of the component of the force is directly to the displacement of the magnitude of its displacement. Work done is equal to component of force into displacement. That is, you can write F d cos theta in short, or Fs cos theta, where in general you are writing as F is equal to F cos theta S, where S is displacement and F is the force. Now work done when the parallel force is applied on the object. Suppose you are pushing anything, so what it will be? So Fs cos theta, your cos theta is 0, so here it will be, work done will be Fs, that is maximum work. Now suppose a work done by a applied force or obliged force, you can say an angle, so you will get a Fs cos theta. So here the work done is also dependent on the theta. Force is resolved into a two triangular components. F sin theta acting in the vertical direction does not displace the body in the direction, therefore the work done of the component F sin theta is 0. F cos theta acting on the horizontal direction displacement of the body, that is in the direction. See, you can see a man is pushing or pulling an object. Here cos and sin theta both is applied, but it is not moving up, it is moving forward because the direction is with respect to the force applied by that man. Therefore work done is equal to force component into displacement, that is F as cos theta here in this case. Now when work done is 0, for example, A work is to be done, both force, a component of the force, and displacement must be present in the body. If a force is applied on the body, it does not produce a displacement in the body, the scientifically no work is done. For example, consider you are sitting in one place. Think you are sitting in the school, gone home, come back next day and sit on the same place. Scientifically, you have not done any work. Work done is zero because displacement is zero. Other example, sun is rotating in the solar system and planets are rotating around the sun. At one point, when we are at the one place around the sun and coming back to that position, and same that position, the work done by the planet is zero. See, a man holding a book in the hand in the stationary position does not work, since the height of the book acting on him does produce the displacement. The man trying to push a rigid and stationary wall does not do the work, since the force applied by him does not move the wall. Here the friction is absent and the body is under the uniform motion. So what you can say? Some points about the work. It is first scalar quantity, positive, 0 or negative. Negative work does means a vector quantity. Work done by the friction has negative, as the displacement is opposite to the friction. Its dimension is ml square t raised to minus 2. Unit joule. Remember, 1 joule is equal to 1 Newton into 1 meter, or 1 joule is equal to 1 Newton meter. Thus you can give a definition that 1 joule of the amount done by 1 Newton of the force acting on the body displaced through a 1 meter. In CGS unit, you can write 1 erg is equal to 10 raised to minus 7 joule. 1 joule is equal to 10 raised to 7 erg. 1 EV is equal to 1.6 into 10 raised to minus 19 joule. 1 calorie is equal to 4.186 joules. 1 kilowatt 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Positive, 0 or negative work done. When your theta is between 0 to 90, work done is positive. You can see on the screen such that the body is in the direction and of its motion. Second case, when it is in the perpendicular direction, the theta is 90 exactly, that time work done will be a 0. Between 90 to 180, it can have a negative. Work done is negative if the force act on the body is in the direction opposite to the motion. It can stop, it can push to a backward direction or another direction, depends on the angle and force. For example, work done by the gravitational force on the satellite is 0 because the force acting perpendicular to the direction of the motion to satellite. This here work done is 0. Similarly, work done by the sun on the earth is 0. When we throw a ball vertically upwards, the work done by the force is positively, whereas work done by the gravitational force is negatively, since it acts in the direction opposite to the motion of the ball. when the ball back and work done by the gravitational force is positive since it acts along the direction of the ball. Work done by variable forces. See on the screen a graph F versus displacement. It is moving and changing. It depends on the theta and work done and the position and the force you are applied. The displacement covered by the body from one place to another to be made of the infinitive number of the small sections. Thus the work done delta W you will get Fx delta x, and total summation of the work you can find summation of Fx dx. Limit delta x tends to 0, summation of Fx dx will give you W is equal to integration of Fx dx. Thus varying force of work done can be expressed by defined integral over the force displacement. Energy. What is energy? It is just ability to do work. If any object wants to do work, he needs energy or it needs energy. The amount of energy possessed by the body, it's equal to the amount of the work done can be do when its energy is released. Remember, it is a scalar quantity. Its units are joule in SI unit, erg in CGS unit. 1 erg is equal to 10 raised to minus 7 joule. Energy can be in different forms. You are learning from the 6th or 7th standard. Even the laws you are learning from childhood. For example, mechanical energy, which is converted into a potential kinetic energy, heat energy, sound energy, electrical energy, nuclear energy, light energy, chemical energy, magnetic energy, etc., etc., etc. The laws is very famous for the energy, that it cannot be created, not destroyed, only just can be converted from one form to another. Other property of the energy or the characteristic of energy, that it cannot be destroyed. That is very important. It can be just converted into a one form to another. The total amount of the energy in the universe always remains constant. Kinetic energy. Kinetic energy is defined as the energy of a body by object of its motion. When it is in the motion, you know that when object is in the motion, it gives a kinetic energy. When you are walking, a cricket ball thrown, it gives a kinetic energy. When you are sitting, having a different kind of energy. When you are walking, it gives a kinetic energy. Kinetic energy. What is formula? Suppose a body of a mass moving with the velocity acted upon the force for the time t, the velocity of the final velocity and the displacement s on the body at the end of the time, you will get W is equal to F into S, where F is equal to ma, second law of motion we have learned in the previous chapter. So you can write MAS, in short, W, that is equal to work done. Now we know that V square is equal to U square plus 2S, that is equation for the displacement. Just place that, you will get that work done is equal to half mv square V square U square. Work done is possessed by the body in the form of kinetic energy. Thus you can write W is equal to Ke is equal to half mv square U square V square. But initially you are considering that your as 0. So you can write the body in the initial as the rest and the final is the V. So then you will write K is equal to half mv square. Remember that kinetic energy is directly proportional to the mass of an object, directly proportional to the square of the velocity of its body. If the object is double, the kinetic energy is doubled, and the object is half, the kinetic is also energy half. So if you are changing a mass of an object, its kinetic energy will change, although you are giving the same force on the object. The velocity is double, the kinetic energy increases 4 times, and the mass is halved, the kinetic energy reduced to 1 upon 4 to its original value. 1 upon 4 to its original value. That's an important point. Kinetic energy is always positive. Why? It cannot be a negative. The mass is positive. Even if the velocity is negative, the square of the velocity will be positive. Therefore, the kinetic energy is always positive. Half mv square. Mass is positive. Half is constant. V is square. So anything squared will give you a positive value only. Kinetic energy is a scalar quantity. The term speed can be used in the place of velocity in the formula for the kinetic energy.